For example 1, I'd like to solve a couple of exponential equations. So we're starting with a couple of very basic ones where you can just hopefully guess the answer. So here we have 2 to the x is equal to 8. We'll start with that one. Right, if I put 3 in place of x, 2 cubed is 2 times 2 times 2, which is 8. So I know that's the answer. But I want to use this to get a strategy going for solving an equation like this. And a simple way to do that is to use the base of 2 on both sides of my equation, in that I know 8 is the same thing as 2 cubed. And the second that you have the bases are both equal, you can set the exponents equal to each other and just write down x is equal to 3. I mean, there's no other work to do because I know this is the answer, but again, this is to illustrate the strategy for solving an exponential equation. Make the bases on the left and the right side equal. Now, to try this out for my other example of 5 to the x is equal to 125, again, the idea is, can you take 125 and write that in a way so it's 5 to a certain power? So it's not 1, it's not 2. Hopefully it should work out to be something that you could actually guess, but actually it's going to be 3 again. 5 times 5 times 5 is 25, which would then give you 125. So 5 to the x is equal to 5 to the power of 3. And so once you're here, the bases are the same, so you can simply just take the exponent on the left, the exponent on the right to get your answer. So for both of these equations, the answer was 3, but the strategy is to get the bases the same on the left and the right. So we will use that strategy in example 1 to make something like perhaps slightly more complicated, but alright, I want to solve 3 to the 5 minus x is equal to 27. And even though the left side has an exponent that's more complicated, our previous strategy can still work, provided that I can write 27 as 3 to a certain power. I guess I'm choosing 3 for all of these, but 3 cubed is in fact 27. So at this point, you can say, well, since the bases are equal, I can take this exponent on the left and the other one on the right and say 5 minus x is 3. Okay, so now you have to do a little bit more work to actually get your answer, but now that you've removed the terms from the exponents, I'm left with this linear equation where I'm going to add x to both sides and subtract 3 from both sides. So I get 2 on the left, I get x on the right, my solution is x is equal to 2. And you can even check to see that this is true. You could say, well, I'll go back to my original equation, I'll put 2 in place of the x and make sure this thing does in fact equal 27, and it does. You get 3 in the exponent, and 3 cubed is 27. Okay, so hopefully something just a little bit more complicated here. Like this is already looking more confusing. I have 1/2 to the 2x minus 1 is equal to 16 to the 3x plus 7. And I still want to use the same strategy of I want my bases to be the same. And here I'm comparing 1/2 and 16. Well, if I ever see a fraction, I would immediately change this. So it's going to be 2 to the negative 1. If possible, rewrite it so you're not really dealing with a fraction. And the way to do this is by using a negative exponent. And 16, it's already set up, it has an exponent of 1. Oh, but now I can think of, well, 16 is 4 times 4, but 4 is 2 times 2. I can write 16 as 2 to the 4th. So now I'm actually comparing like bases. So I'm now going to make these substitutions. I'm going to write this original equation as 2 to the negative 1, and I'll copy down my exponent of 2x minus 1. This is equal to 2 to the 4th, and I have 3x plus 7. So I've switched my equation so my bases are the same. Now I just have to be a little bit careful with my rules of exponents. So on the left, I have this negative 1 here, and I have this 2x minus 1. And the rules for exponents state that we would just multiply these two exponents together. The same thing would go for this 4 and this 3x plus 7. I'm going to take the product of those two things. That way I'm left with just one value as my base instead of like a 2 and a negative 1 or a 2 and a positive 4. So I'm going to switch this to 2, and then I have negative 1 times 2x minus 1. On the other side I have 2, but the exponent is 4 times 3x plus 7. So now you actually can just get rid of the base of 2 altogether. This is just negative 1 times 2x minus 1 is equal to 4 times 3x plus 7. A really simple linear equation. I'll distribute the negative 1, and I'll distribute the 4, and all I have to do now is add 2x to both sides and subtract 28. I'll divide both sides by 14, and here is my answer. X is equal to negative 27/14. So not as obvious of an answer to guess, but that one number, when you go back to the original equation, should make the left side equal the right side. So try it out if you'd like, but here's our solution.